Hello grade 12s, welcome back to the channel Science Therapy, hosted by the one and only science therapist Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 7, still on electric circuit. It says in the circuit below, the battery has an EMF of 24 volt and an internal resistance of 0.6 ohms. The heater has a resistance of 10 ohm, so as we can see the heater here, and the fixed resistor is a resistance of 30 ohm, right? So this is the fixed resistor. Then the variable resistor, indicated by this here, can change between 0 ohm and 15 ohm, right? So the variable resistor is what we know as the rheostat. Now 7.1 says the variable resistor R is set at a resistance of 3.5 ohms. So note that they say you can change it between 0 ohm to 15 ohm. And now they decided to set it at 3.5 ohm. Now 7.1.1 says calculate the total resistance of the circuit, including the battery. Now if they say including the battery, that means you also have to include the internal resistance, right? So also include the resistance of the battery, which is known as the internal resistance. There's 0.6 ohms here. So how are we going to calculate that? We already know that the 10 ohm here and the 30 ohm, they are connected in parallel, right? And the variable resistor here is the one that is connected in series, right? So obviously we know that to calculate the R external, we simply just say the resistance of the parallel plus the resistance of the series. But then the R total will have to be the R external plus the internal resistance. So that means, in other words, to find the R total, we have to say the resistance of the parallel plus the resistance of the series plus the internal resistance. Now obviously the first thing that we need to calculate here is the resistance in the parallel, right? So we can simply calculate that using our product over sum formula, which goes R1 multiplied by R2 over R1 plus R2. So we have two resistors in parallel, meaning we can do that. So that's 10 multiplied by 30 over 10 plus 30, right? Now when you punch all that into your calculator, you get the resistance of the parallel will be equals to 7.5 ohms, right? Then the resistance in series, remember, we've been told that it's 3.5 ohms, right? So in order to calculate the total resistance now, we'll say RT is equals to resistance of parallel is 7.5, resistance of the series is 3.5, and then the internal resistance is that 0.6. Now you have to add all of this, and then you get 11.6 ohms. So that becomes your total resistance, right? So note that the total resistance includes also the internal resistance. So 5 marks for all of that. That's all you were supposed to do. Now okay, let's proceed. We have 7.1.2. It says calculate the current measured by the ammeter A2, right? So we can see A2 here measures only the current that flows on the heater there. So in order to know that, we obviously need to know the total current that flows in here, right? So that's the first mission. So we can easily calculate that by saying, okay, 7.1.2 can use the formula EMF is equals to the current and then the R external plus the R internal, right? The EMF we've been given here, even from the statement here, 24 volts. So we have 24, and then the current. Now remember that we already have the solution to this one from 7.1.1. This represents the total resistance, since it's the external resistance plus the internal resistance. So that will be 11.6. And then divide both sides by 11.6. Then the total current will now be 2.0 0.07 amperes rounded off to 2 decimal places. But then remember, we are more concerned about the current that flows through the heater there. So in order to get that, we can use the ratios. Remember, if these are connected in parallel, we can simply say what is the ratio of the 10 ohm resistor to the 30 ohm resistor. Now simplifying the ratio here, obviously we will have to divide by the smallest number both sides, which our simplified ratio will be 1:3. So if we say 10 divided by 10, that's 1. 30 divided by 10, that's 3. Now understand this. I want you to understand how we use the ratios. We know that resistance is inversely proportional to current. So if we want to calculate the current that flows through the heater there, this is what we're gonna do, right? So we want to calculate the current passing through the 10 ohm resistor or the heater. Because the resistance is inversely proportional to current, what we will do is we will take the ratio. So we kind of inverse this. We will take the ratio of the resistance of the 30 ohm resistor here, and then we'll divide it over the total of the ratios. Now the total of the ratios, how do we find it? We simply find it by saying, 1 plus 3, this will give us 4. Right, so if we add the ratios, then we find the total of the ratios. Then that's what we're going to use there. So we're going to say 3/4. Note that we want the current of the 10 ohm resistor, but because it's inversely proportional, that means we have to take the ratio of the 30 ohm resistor over the total of the ratios, then multiply it by the total current that flows throughout the circuit. So that's 2.07 amperes. Now when we punch that, we get 1.55 amperes, and this represents the current of the 10 ohm resistor or the heat. So it's 1.55 amperes. So note how we calculate that. If we wanted the current through the 30 ohm resistor, then this time around we were supposed to say 1/4. But if we want the current through the 10 ohm resistor, we say 3/4. Right? So okay, nice. I hope that makes sense, and then you are able to understand that. So you can play the video as many times as possible and just try to understand the approach that I took there. Okay, and then now let's proceed to 7.2. Now 7.2 says the variable resistor is now adjusted to have an even higher resistance value. So that means they now move from 3.5 ohms. Now let's say maybe they turn it to 15 ohms, which is the maximum that they can have. Now what they're asking here is, how will this affect the power dissipated by the heat? Right? Only increases, decreases, or remains the same. Then after, explain the answer by making use of a suitable equation. Right? So now let's quickly run to that. 3 marks, so we know having to choose whether it will increase, decrease, or remain the same, it's a mark, and then our explanation for 2 marks. So let's quickly run to that. How do we explain 7.2? We say the solution has to be decreases, and the explanation says increasing R. So let's suppose that we are increasing this here to 15 ohms, right? Now having to increase R here will obviously increase the total resistance. So if you were to calculate right now the R total, you would find that it has increased as a result of you having to increase the value of R, and thus this decreases the total current. Brings us to this same relationship again. If we are increasing R, if they're inversely proportional, what must happen to current? It must decrease, right? So having to increase R increases the total resistance, which decreases the total current. But we are talking about power, so that's the suitable equation we will use. According to power is equal to I squared times R, we know that power is directly proportional to current. So a decrease in current results in a decrease in the power dissipated by the heat. So if there is a decrease in current, then there is also a decrease in the power dissipated. Okay, so that's how you were supposed to explain that. and then all that for a total of 11 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.